Hello friends, in this tutorial we will be dealing with fluid pressure at a point and the variation of pressure in a fluid. So first we will be dealing with fluid pressure at a point, fluid pressure at a point. So what is a pressure? The pressure is, what is pressure? Pressure is the force divided by area. So if you are acting a force F in an area that is having an area, the pressure is the force acting per unit area. Pressure is the force per unit area. This will be true in case if the force acting is uniformly distributed, or the constant force or the uniform force across the area of A. If F is a uniform force, then this P will be F by A. So in case of the varying force, this is the area and this is the force parameter, the force. You cannot take the total pressure is equal to pressure not equal to total force by area. So here you have this, you have to calculate the pressure at every single point. So the pressure is here is called dP, the small pressure, and this small pressure, how to calculate this pressure? This will be the force, the part of the force acting here, that is this much force, or dF, divided by this much area, dA. So dP is, or the pressure is equal to small force divided by small area in case of varying area and the varying force. Even if one is varying, you have to take this dF by dA. So this is the basic concept of pressure pressure. So in case of fluid, you consider a container. So this is your container. Force is acting here. You have the fluid. The fluid will exert a pressure on the boundaries, on all the boundaries of the container, and at the inner molecular also there will be a pressure. So here the pressure will be due to the self weight of the water or the fluid. Okay, so this is the concept of what is basic fluid pressure at a point. And the one more thing, that since at the rest position there is no movement of the fluid, you have to note this as, if there is a shear stress acting, the fluid cannot withstand shear stress and there will be movement. Since there is no movement, it means shear stress is equal to 0. Also, what it means, if we extend this portion, like this is the container portion, this is the container portion, this container, and here the force, the fluid is exerting a pressure on the wall of the container, then this pressure will be normal. This pressure or the force will be normal. It's because that if there is any inclination, then there will be a component in the direction or tangential to the liquid. So if there is a component tangential to the liquid, there will be movement. Since there is no movement, all the forces acting in a static fluid is normal to the container. So this is the basic concept of fluid pressure at a point in a static fluid. Now we will consider the variation of fluid pressure. For that, we take a small cubic element from the fluid, the total fluid. We will take a small cubic element, and it is the so we are taking so this is your small cubic element, x direction, y direction. This is in the z direction. Okay, so now we will consider the pressure at the center portion. Note that it is a 3D figure, and we will take the pressure at the center of the cube. So consider this as a 3D at the center portion. So the pressure at the center is taken as small p. Small p is the pressure at the center. So before that, we have to take this as the dx, this is dz, and this is dy. Pressure at the point, at the midpoint, the pressure midpoint, the midpoint pressure is equal to p, small p. Pressure is equal to small p. Okay, so at the left, or at the left end, you take this as the left end. At the left end, the pressure is, we will take the pressure as P is equal to, take the pressure as P is equal to this small p minus the change in the P, or the change in the pressure with respect to the x direction, that is dou P by dou x with respect to x direction into that distance. So this, what is this distance? It is the midpoint of, so dx by 2, pressure at the left, pressure at the left end of, left face of the element. So pressure at left face P is equal to, so pressure, now pressure at right end is equal to P plus, that is P plus change, that is dou P by dou x again, into that distance, that is dx by 2. So this is the pressure at the two end faces of the cube. So in the x direction, since it is in equilibrium, since it is in rest condition, the equilibrium condition will be satisfied. So at sigma fx is equal to 0. So this implies the force at the x direction is 0. So what are the forces acting in the x direction? Forces acting in the x direction are pressure at the left end, that is acting here, pressure at the left end, and this, since it is in equilibrium, it is an equivalent opposite force will be acting here, that is here, two forces. So what are the forces? Pressure at the left face, that is P minus dou P by dou x into dx by 2. This is the pressure into that area. What is that area? dz into dy. This plus this is in the x direction. Let us take this as the positive, this as negative. Sorry, this as negative. This is positive, this is negative. So plus it is in the negative direction, minus on the right side, minus P plus dou P by dou x into dx by 2 is equal to, what is that value? 0. So what it means the P dz dy into, sorry, this is not equal to 0, into that area. What is that area? This area is again dz into dy. dz into dy. This is whole is equal to 0. So what it means that P and P into dz by dy, here minus P into dz by dy, it will cancel out. Here minus dou P by dou x into dx by 2 into dz dy minus dou P by dou x dx by 2 dz dy. So it will become minus 2 dou P by dou x. 2 dou P by dou x into dx by 2 into dz into dy is equal to 0. What it means? It means that minus 2 and this 2 will be cancelled out, and consider this equation. This equation considering this cannot be 0 because it is an area. Sorry, it is an volume. So to become this equation equal to 0, the only condition is dou P by dou x should be equal to 0. What it means? There is no change in the P, that is the pressure in the x direction. Similarly, we consider the y direction, that is here. Here the y direction. So this is, you can take this as the positive direction, this is the negative direction. Let us take it as a three-dimensional coordinate system. So here this is the value. What is the value? It is P minus dou P by, in the y direction, that is dou y, into dy by d2. I think in this way. Here it is P plus dou P by dou y into dy by 2. So these are the two pressure forces acting. So in the y direction, we take equilibrium in y direction. It becomes that P minus dou P by dou y into dy by dy by 2. Here it is not d2, it is dy by 2. Sorry for that, it is dy by 2. So dy by 2 into the area is dz into dx. It is let's take it as positive direction because it is acting in the positive direction, plus minus p plus dou p by minus of p plus dou p by dou y into dy by 2 whole into dz into dx is equal to, what is the value? These are the two forces acting in the y direction. Since it is in equilibrium condition, this is equal to 0. By solving this equation, we will have and the same as we got in the x direction, that is it will cancel out this p dz dx minus p d minus p into dz dx will cancel out, and we will get minus 2 into dou p by dou y into dy by 2 into dz into dx is equal to 0. 2 will cancel out. It means dou p by dou y will be equal to 0. So this means that there is no variation in the pressure in the y direction also. So we have got that there is no variation in the x direction, there is no variation in the y direction. Okay, so now we will consider consider z direction. Consider z direction. In z direction, what is the case? What is the case is, in the z direction you have the force as P, that is P, it is, we take it as positive direction, that is P plus positive direction plus dou P by, it is in Z direction, that is dou Z into, it is the midpoint of dz, that is dz by 2, positive direction. Okay, so in the other phase this will be in the opposite direction, that is to this side, that is, what is the value? P minus dou p by dou z into dz by 2. So these are the two forces acting in the z direction, and remember here is one more forces here. It is very important to note here is that it is the weight of, we will mark it with another color, the weight of fluid element. So what is that weight of fluid element? It is equal to specific weight, but that is weight per unit volume, W into volume of the element. What is that volume of the element? It is dz into dx into dz into dx into dy. It is the volume of the element. Okay, so consider the equation in the z direction we have. So now we will take the equation in the z direction. Consider z direction. So the equation is, first the force in the bottom face. Force in the bottom face, that is P minus dou P by dou Z into dz by 2. Dou P by dou Z into dz by 2. This into the area is dx into dy. So what is the sign of this? It will be positive. What is? It's because the positive direction is this one. This is the positive direction. We have seen this. So all the forces in the positive direction is taken as that. This one. All the forces in the positive direction is taken as positive. So here will positive direction plus the other force is this one. It is in the negative direction, minus of P plus dou p by dou z into dz by 2 into dx into dy. So in all other cases we equate this to 0, but in this case we have one more force is there and it is in the negative direction. It is in the negative direction. So what is that force? It is the force of or the weight of the fluid element itself, that is this whole minus specific weight w into dz into dx into dy whole is equal to 0. So now we have what are the value we got this p into dx dy. Here p into dx dy, this plus and minus will cancel out and this 2 minus will be add up. So it is becoming minus dou p by dou z minus dou p by dou z into dz 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 dx dy minus w dz dx dy equal to 0. So from here we have minus dou p by dou z minus dou p by dou z minus w into dz dx dy equal to 0. It means that this dz dx dy cannot be 0, so it implies minus dou p by dou z is equal to the what is equal to w. Or since we have seen that there is no variation of p with respect to x and y, now this minus dou p by dou z will become p will become a variable in the one dimension only. So we can write it as minus dp by dz is equal to w, that is a specific weight. Okay, so the variation of the pressure is in the z direction and the rate of that variation is equal to specific weight, or dp by dz is equal to, or the value dp by dz is equal to that w or minus w. So minus indicates that we have taken this as the positive direction. So the positive direction, and when we go from below bottom to top, there is a decrease in, there is a bottom to top, there is a decrease in the pressure that is shown by this minus sign. Okay, so the pressure variation in the z direction, you can take a container containing liquid here, liquid. The pressure variation in the z direction, that is from bottom to top, because we have taken this as positive. From bottom to top it is dou p by or dp by dz. dp by dz is equal to dp by dz is equal to w or minus w. So since we have taken from here, so what will be the value if we take the z direction from here? If you take z from, or the height from here, if you take this is the origin, this level as the origin, water surface as the origin, the equation will become dp by dz is equal to w. So now you can integrate that dp is equal to w into dz. Now integrate from 0 to h, that dp is equal to, or integral dp, or the pressure is equal to, now we have the variation in the pressure as dp by dz is equal to minus w. So this is the origin, and this is the variation direction, z direction. Now what will happen if you take this as the origin, this is the direction, the equation will become dp by dz is equal to the minus of this minus w, minus of the opposite of, since this is the opposite of this one, the equation also will become opposite, minus of minus w equal to dp by dz is equal to w. So we have dp by dz is equal to w for this origin z direction. So dp is equal to w dz. So the integration of w dz will give you the total pressure at any point. So pressure at any point, this is the h height. So pressure at h, you will get pressure at h as p is equal to integral of w dz from the origin up to the h, from 0 to h. The value is p h, you can take pressure at h is equal to, the w can be taken outside for what? For compressible fluids. Sorry, incompressible fluids, the w is constant and it can be taken outside, 0 to h dz for incompressible fluids. So pH is equal to w into the dz, integration is z from 0 to h, 0 to h, sorry, 0 to h, that is pH is equal to w into h minus 0 is equal to pH is equal to w into h. So the w can be written as gamma, so unit weight, or also gamma into h. This is the pressure at any point in a liquid, and this pressure is not varying with respect to x and y-axis for a static fluid, and it will be varying only with respect to z-axis, so that pressure is constant throughout the horizontal plane. It is an important concept. Pressure is constant throughout an horizontal plane. Now if you have a pipe You have a pipe here, water is flowing through the pipe, and if you place a glass tube here, you place a glass tube here, and you place one glass tube in the shape of this one in the shape of this one. So this is the water flowing, and you will get the same water level in every shape of glass tube. It is because that the pressure is only depend on the pressure at this point is same, and this pressure is only depend on the height of the liquid and not on the shape of the container of the liquid. Okay, so even though these shapes are different, you will get the same water level because the same pressure is acting here. So this is the point of the horizontal pressure is constant throughout the liquid in a static condition, and if it is flowing, then there will be another changes due to the frictional loss, and we will deal or we will discuss it in the other tutorials. So thank you guys, and if you like the video, please share and like this video, and don't forget to subscribe the channel for more videos. Thank you.